Hi everyone, and welcome to the Eco Concrete Uganda YouTube channel. Today's tutorial explains the construction procedure of crib retaining walls using Eco Retiners. And I request at the end of this video, please like, comment and subscribe. We shall indeed be grateful for that feedback. The construction of crib retaining walls can be a complex undertaking right from their design stages, and in this case a client out there needs to involve experienced people as they go about the construction. And one of the most important and preliminary requirements is the acquisition of relevant architecture and structure designs and layout, which will guide in the overall construction process. So after the designs have been approved, you can then embark on the construction process that starts with excavation. And during the excavation, our major aim here is to cut out a strip of natural soil, as you can see below, which will then be backfilled as reinforced soil. And an excavator can be used during the excavation. However, for less complex construction, for example, if a wall is just 1 meter high, simple hand tools such as hoes can be used during the excavation. The excavation should also comprise the foundation trench, which should be wide and deep enough to accommodate the size of the leveling pad. So after excavation, the subgrade should then be compacted well enough to 95% standard proctor, and if in any case it comprises poor soils, these soils will have to be stabilized or removed and replaced with better soils. And the final stage concerning the foundation is casting of the concrete leveling pad. The second stage comprises assembling of the Eco Retiners, and this is the stage where the construction becomes fast, easy and user-friendly, for you do not require skills of experienced masons and many years of training. So we start by placing the Eco Retiners directly along the center line of the leveling pad, taking care to follow the desired alignment of the wall. Now, since the units are hollow, the cavities are then filled with gravel and the infill is compacted. This infill helps to increase the mass and stability of the retainer, and it also accommodates vegetation of flowers in case the client needs the green appearance. So after the first course, we then place a drainage pipe of minimum diameter 4 inches behind the wall, and this helps in collecting and draining away groundwater. This pipe should be sloped and also have an outlet at the end of the wall. After we then fill and compact in layers not exceeding 300 millimeters, and this means that only one course should be placed at a time before backfilling. One point to note here is that care should be taken so that the units are not moved out of alignment during the backfilling. Another point is at least 12 inches of crushed stone should be placed behind the wall to facilitate drainage. So this procedure is repeated for the remaining courses, and it is done by dry stacking until we have reached the desired height. So no mortar will be required in the assembling of these units. Another important stage of the construction is placing of lateral reinforcement. So the geogrid is placed on top of a fully assembled and backfilled course of Eco Retainers. After placing the geogrid, another course of retainers is placed on the geogrid. The geogrid is then tensioned with stakes or by hand tensioning. After that, we backfill and then compact. A point to note here is that the number of layers and length of geogrid will depend on several conditions, which may include the type of soil being retained and the overall height of the wall. In the next slide, I'm going to share about wall butter and other special considerations such as corners and curves. Creating wall butter in segmental retaining walls involves inclining the wall face backward slightly as it rises. This technique provides stability, especially for tall walls, and it does this by distributing the pressure of the retained soil more evenly. So here is how to achieve wall butter in crib retaining walls. So as you assemble each course upwards, set each course slightly back from the front edge of the lower course. This setback creates the butter angle, and the amount of setback will depend on the desired slope of the retaining wall. Another important aspect we need to talk about is incorporating corners and curves, which reflects how flexible a crib retaining wall is. However, extra care has to be taken to ensure that the curve has been set out correctly right from the foundation to the topmost courses. And during the assembling, it is more recommended to start laying the units from the corner onwards to the straight section, as in the photo below. And when it comes to addition of geogrid at curved section, we ensure that the geogrid is placed in a manner that eliminates gaps left by the previous layer of geogrid. So the application of geogrid in corners and curves will differ from that of straight section. There are also other special considerations for cases such as staircases, stepped sections, and tiered walls. So in such cases, the wall will be treated quite differently. And next, I'm going to talk about the components of the finished wall, since some of them were not clearly illustrated in the photos from the previous slides. And the first component is the precast units or Eco Retainers. I believe that is clear enough. The second component is the backfilled or reinforced soil, and this is the soil that we initially removed. So many times property owners, most especially at the upper side, tend to oppose the excavation, claiming that we are cutting away their plot, and it is not easy to convince them that the excavated soil will actually be brought back and in a reinforced form. So the client or the project manager has to establish a good relationship with the neighbors and also explain to them clearly how this wall functions. Then we have the concrete leveling pad, which is in most cases unreinforced concrete, and it is used to distribute the weight of the dry stacked crib units over a wider foundation area. Then there is also a compacted subgrade over there. We have already discussed this. Then we also have a drain pipe and gravel fill, and these facilitate drainage at the face of the wall by intercepting incidental water and thereby relieving hydrostatic pressure. We have the geosynthetic reinforcement or geogrid, We also have the finished grade and embedment depth, and this depth refers to the height of the wall or the number of courses that are buried into the soil, and this is important in providing base stability, which prevents the wall from base sliding, which is one of the failure mechanisms of this wall. Lastly, we have the positioning of the surcharge loads, and these loads include dead loads such as perimeter walls, then live loads, for example, vehicle traffic. So these loads should not be placed directly on top of the crib units, and the engineer should rather leave a clearance of minimum dimensions 1 meter from the top of the crib units. So if in any case the client really wants to construct along this line or very close to it, one solution could be increasing the steepness of the wall, maybe from 70 degrees to 80 degrees, so that one can achieve the required clearance for positioning of the surcharge loads. And in this case, a client will not lose a large portion of their plot. And I think this impression can illustrate better what I'm talking about. So as you can see, where the top arrow is, that is the strip or clearance that I'm talking about. You can actually plant grass or flowers along it, and the same applies to the bottom part. So the engineer has to guide on how much space or clearance that should be left in order to avoid destabilizing the wall. Then lastly, after the wall has been constructed to the top, there are a number of practices that can be done to protect the wall and also improve its appearance. And some of them may actually be done during the construction. The first practice is surface leveling, both at the top and the bottom of the wall. And this is purposely done to keep water away from the retaining walls, and we also have to provide adequate drainage structures such as trenches. Secondly, you can also plant flowers or vegetation. You can put them at the top, at the bottom, and also within the eco retainers, and this can help to improve the wall appearance and also reduce soil erosion. Thirdly, inspection and maintenance, and this inspection has to be done right from the start of the project so that errors can be identified and corrected quickly. So even after constructing the wall, there could be utility components close to the wall, such as water pipes, electric cables, and other features that could have an impact on the performance of the wall. So the client has to keep track on what's going on in the proximity of their wall. Then finally, the client has to prevent activities that could affect wall stability. For example, no excavation or construction should be done close to the wall without consulting the engineer, because it will lead to addition of surcharge loads that were not designed for at the start of the project. So that's it. Thank you very much for watching. Please visit our social media platforms for more information concerning the crib retaining wall and other related information. See you in the next video.